Hi lads, how are we getting on today? So today then what we're going to do is I'm going to go through two of the questions that you did yesterday, and I'm going to do two more examples, and then I'm going to give you some questions to do for today, okay? So the first question I'm going to run through then is question 1, part 3. So you all should have this done so you can correct it, or if you were stuck you can fix it. Alright lads, so lads, make sure when you're doing these questions, if you're stuck or you're struggling and you want us to go through it the next day, make sure you let us know, okay? And make sure if you're not sure of something, you ask, lads. There's no point in sitting there not having a clue and then saying next February when you haven't got a clue for your mock, saying, oh sure, I didn't have a clue what we were doing when we were doing that, sure we done that on online learning, sure I don't have a clue. So I don't want to hear any of that next year. Alright, so make sure that if you're stuck or you're struggling, you're asking questions, and make sure you're submitting all your work as well, alright? Have to be seeing more work from our 5th years, so make sure you're handling all your work. So question 1, part 3 then, find the area of the shaded sector in terms of pi and then correct 2 decimal places, okay? So we're given this angle here, which is 150 degrees. We're given a radius, which is 18 centimeters. Okay, so we're trying to find the area of this shaded region here. So the area of a sector then from our log tables is A is equal to pi r squared. So that's in the log tables. Multiply it by theta over 360, and it's always the degrees one, okay? And it's in the log table, so you don't have to learn it off, you just have to know how to use it. Okay, so we're asked for the area of the shaded region, lads. So we need to find the angle of the shaded region. Okay, so how much degrees is in a full circle? There is 360. We know that this part of it is 150, the unshaded region, so if we take away 150, we're getting 210. Okay, so that angle there is 210. Okay, so now we're looking for the area, so that might have caught a few people out there that some people might use 150 instead of the 210, so just be aware of what you're looking at, okay? So if you're looking for the area of the shaded region, it's the angle within the shaded region that we're using, okay? So then we're subbing in to our formula. So A is what we're looking for, it's the area, so we're leaving that as A, is equal to pi by r. So instead of my r, I know the radius is 18 centimeters. So instead of r, I'm now putting in 18. I know that r is equal to 18, and it's to be squared, according to the formula, by theta, so we know our angle then is 210, all over 360, close the bracket. So A then is equal to pi by 18 squared is 324, so use your calculator, and 210 divided by 360 is the same as 7 over 12. So A then is equal to 324, multiply it by 7 over 12, is 189 pi, and that's centimeters squared because our radius is in centimeters. Okay, so that's part A then. So part B then asks for correct 2 decimal places. So it's 189 multiplied by, and our pi button's down here, guys. Okay, here's our pi button, so shift and this button here. That's where pi is, equals, and then you have to hit the S to D. So area is equal to 593.76 centimeters squared. okay? So 593.76 centimeters squared. Let's hit the yesterday one. So I hope that's okay for you lads. If you have any questions, lads, make sure you know. Make sure you let us know, okay? Make sure you tell us. So I'm going to go on now and I'm going to do question 2, part 3. Okay, so this question asks us to find the length of the minor arc AB, so shaded there first. So the length of the arc is just this length here. Okay, in terms of pi, and then correct to 2 decimal places. So again, we're going to our log tables and we're going to see what L is equal to. We're going to get that formula. So in the log tables we are told that L is equal to 2 pi r by theta over 360. Okay, so L is our length, so that's what we're looking for. So L is equal to 2 by pi by r. So our r then is given to us in the question. It's 30 centimeters by theta then, so our angle that we're looking at is 170 degrees over 360. Okay, so L then is equal to 2 by 30 is 60 pi by 17 over 36. L then is equal to 60 pi 17 over 36, close your bracket, equals, and it's 85 over 3 pi, and that's centimeters. Okay, centimeters because our radius is in centimeters. So that's part A. Part B then asks for it correct 2 decimal places. So we just hit the yesterday button when we've that done. So it's 89.01 centimeters. Okay. So hopefully that's okay for you then, lads, alright? So again, any questions, let us know, okay? So then guys, hopefully the homework was okay, the work that you did. The next question I'm going to look at, I'm going to continue on with the arcs. So I'm going to do 2 questions on these questions, okay? So we're going to do question 3 part I. So it's on page 541 of your book. And we're asked here to find theta. So we know that the radius is 6, looking at here. Our angle is theta, and the area of the sector is 6 pi, okay, centimeters squared. So we're trying to find theta. So we're given the area. So I'm going to write out the formula for the area. So area is equal to pi r squared by theta over 360. Okay, so pi r squared by theta over 360. Again, guys, that's in the log tables. So we just have to know where to find it, okay, and how to use it. So again, it's always the degree formula. So now we're going to sub in what we know for this formula, okay. So we know that the area is 6 pi. So instead of A now, I'm going to put in 6 pi because we know that the area is equal to 6 pi is equal to pi r squared. So my r is 6, my radius is equal to 6. So instead of my r, I'm putting in 6 because that's my radius. It's to be squared over theta over 360. Okay, we don't know what theta is. That's what we're trying to find. So 6 pi then is equal to 6 squared is 36 pi by theta over 360. So my 36 came from squaring 6, so 6 sixes is 36. My pi came down, my theta over 360 came down. So hopefully you can see where all that's coming from, boys. If not, you need to let us know. If you don't know where any of those figures are coming from, you need to say so. Okay? Now we just need to tidy this up to try to get theta on its own. So again, this 36 pi is being multiplied by theta over 360. So we're going to get rid of this 36 pi. It's multiplication, so we're going to do the opposite and we're going to divide it. So 6 pi divided by 36 pi is equal to 36 pi. So remember, with the equation, to keep it equal, what we do to one side, we have to do to the other. So pi divided by pi goes once, and 6 divided by 36 is 1 over 6 is equal to 36 divided by 36 goes once, pi into pi goes once, left with 1. So 1 multiplied by theta over 360 is just theta over 360. Okay, so we nearly have theta on its own. The only thing that's stopping us is that divided by 36. So lads, we all know now hopefully that that line there means division. Okay, that line actually means that theta is divided by 36. Okay, that's what that line is. So we are going to do the opposite. So we're going to multiply by 360. Multiply by 360. So theta is divided by 360. So on the calculator then, 360, multiply it by 1 over 6, and we're getting 60 is equal to, so 360 divided by 360 is just 1, so it's gone, so we're just left with theta there. So theta is equal to 60 degrees. So hopefully now lads, you can see where all that's coming from. Okay, so if you go back up here then, our angle there is 60 degrees. Okay, so what did I do? How did I do that question? I was told what the area of the sector was. It was 6 pi. Okay, and I'm asked to find theta. So I'm asked to find that angle. So I know the area of the sector. So I know I'm going to be using that formula. So I go to my log tables and I find the formula. Formula tells me that the area of a sector is equal to pi r squared, multiply it by theta divided by 60. Okay, brackets mean multiplication. Okay, and when there's no sign between the pi and the r squared, the secret sign there is multiplication. Okay, always, if there's no plus or minus sign there, it always means multiplication. Okay, so now I sub into the formula. What do I know about this formula? What information can I put into it? So I was told in the question that the area was equal to 6 pi. So instead of my a, I put in my 6 pi. Okay, my equals comes down, my pi comes down. My r squared then, I was told in the question that the radius, or r, is equal to 6. Okay, so r is equal to 6. So instead of my r now, I'm going to put in a 6. Okay, and it tells me that has to be squared, so I square it. Then I open up my bracket and I bring down my my theta over 360. I don't know what theta is, I'm trying to find it. So I bring down my theta over 360 and close my bracket. So now I'm going to tidy up this equation, okay? So my 6 pi comes down, my equals comes down, and then I square my 6. So 6 sixes is 36, so that's where that's coming from. My pi comes down, and my theta over 360 comes down. Okay? So now I've tidied up all I can. I'm trying to manipulate this now to get theta on its own. Okay, so how can I get theta on its own? So this 36 pi is being multiplied by theta over 360. So I want to get rid of it to try to get this theta on its own. So I'm going to divide both sides by 36 pi. The equal sign allows me to do that, okay? So I have to do it to both sides to keep my equation equal. So 6 pi divided by 36 pi is equal to 36 pi over 36 pi, and multiplying it by theta over 360. So my pi's divide into each other. So pi divided by pi is just 1, and then 6 divided by 36. So if you put that into the calculator, it's 1 over 6. My equals comes down, 36 pi divided by 36 pi goes once, and 1 multiplied by theta over 360 is just theta over 360. So now I nearly have theta on its own, I just have this divided by 360 to get rid of. Because it's divided by 360, I do the opposite to get rid of it. Okay, so it's divide here, so I multiply it by 360 to get rid of that, to get theta on its own. What I do to one side, I have to do to the other side. Okay, so 360, multiply it by 1/6, and I got 60. And 360 divided by 360 goes once, so we're left with just theta. So theta then is equal to 60 degrees. Alright. So hopefully we all know where everything's coming from in there. Okay. So I'm going to move on then to another example. Okay. So question 4 part I, page 442, exercise 17.9. Alright. So this is what we're given in the question. So we're given this arc, this sector. So we're told the radius is 18 centimeters. Now this length here is 18 centimeters. We're not told what theta is, we're actually asked to find theta in the question. And we're told that the length of the arc is 7 pi. Okay, so we know that the length of this here, so from A to B, is 7 pi. Okay, so we need to try find theta. So we know what the length is, and we're trying to find theta. So we're going to be using the length formula. So I go to my log tables, I look up the formula, and I write it down. And I know that L is equal to 2 pi r by theta over 360. Okay. So now I'm going to sub in what I know. So what do I know about that equation? Okay. Well, the first thing I know is L. I was told in the question that the length of my arc was 7 pi. So instead of my L now, I'm going to put in 7 pi because I know that L is equal to 7 pi. Okay. My equal sign comes down, my 2 comes down, my pi comes down. My r then, I know from the question that my r is equal to 18. So instead of r, I'm putting in 18 because I know that r is equal to 18. Okay, and it's multiplied by theta over 360. We don't know what theta is, we're trying to find it. Okay, so we're only left with one unknown there, which is theta. So 7 pi then comes down is equal to 2 multiplied by 18 is 36, and our pi by theta over 360. Okay, so now we're trying to tidy up this equation to try to get theta on its own. So the first thing I'm going to do is get rid of this 36 pi. There's no sign here, so I know this multiplication. So I know 36 pi is multiplied by theta over 360. So I'm going to divide both sides by 36. Okay, so my pi divided by pi is going to go 1, so they're going to cancel. And I'm just going to be left with 7 over 36 is equal to my 36 pi divided by 36 pi goes once, and 1 multiplied by t over 360 is just t over 360. Okay, so I nearly have t on its own now. I just have this divided by 360 to get rid of. Okay, so it's a divide. This line means divide. Okay, so the opposite to division then is multiplication. So I'm going to multiply it by 360. But remember, it's an equal sign. It's an equation. What I do to one side, I must do to the other. So 7 over 36 then. Multiply it by my 360 equals 70. Is equal to, then 360 divided by 360 is just 1, so we're left with theta. So theta is equal to 70 degrees. So we know that our theta is equal to 70 degrees. Do we all see where all those figures are coming from, lads? So if we're not sure, lads, we need to be asking. Okay? Don't sit there and not have a clue. Make sure you let us know if you don't know something. Some of you are great at asking questions, some of you not so much, so it's hard to know. So make sure you're submitting all your work as well, lads. It's important. We're doing all our work and submitting it. Alright? So I'll just run through that example again, just to be sure, okay? So we're given our arc. We're told that the radius, so from the centre out to the edge, which is the radius, is 18 centimetres. And we're told that the length of the arc is 7 pi centimetres. Okay? And we're asked to find theta, so we're trying to find this angle in there. So I write out my formula. Okay, the formula is in log tables, we don't need to remember it, we just need to know how to use it. So I write out my formula, and it's the degrees formula. So L is equal to 2 pi r by theta over 360. So then I sub in what I know about that equation. Okay, what can I fill in? What information about it do I know? So I know that the length, L, the length of the arc is 7 pi. So instead of my L now, I put in 7 pi. My equal sign comes down, my 2 pi comes down, and multiply it by r then, but I know that r is 18 centimetres. Okay, I'm told in the question that r is equal to 18. So instead of my r, I'm now going to put in 18. I know that value. Okay, I open up my bracket and I bring down my theta over 360. We don't know what theta is. That's what we're trying to find out in this question. Okay, so then I just tidy this up. Okay, so my 7 pi comes down equals 2 multiplied by 18 is 36, and I bring down my pi and I bring down my theta over 360. So now I've done all the tidying up I kind of can. Now I have to manipulate this formula, do something with it, to try to get that theta on its own. So that's what I'm trying to get on its own. So the first thing I'm going to get rid of is this 36 pi. Okay, there is no sign here, so I know that it's been multiplied. These two values are multiplied by each other. So to get rid of it, if it's multiplication, I do the opposite to it. So what's the opposite to multiplication? It is division. So I divide both sides by 36 pi. So 7 pi divided by 36 pi is equal to 36 pi over 36 pi by theta over 360. So my pi's cancel. Pi divided by pi is 1, so I'm left with 7 over 36. My equal sign comes down. 36 pi divided by 36 pi is just 1, so I'm left with theta over 360. Okay, so now I nearly have this t on its own. The only thing stopping me is this minus 3, or divided by 360. Alright, it's theta divided by 360. So I need to get rid of that 360 to get theta on its own. So how do I do that? It's a division here. This line means division. So this 360 is a division. So the opposite to division again is multiplication. So I multiply both sides by 360. Okay, so 360 multiplied by 7 over 36, put it on the calculator, and my answer is 70 degrees. Okay, so I got 70 degrees, and then theta multiplied by 360 is 360 theta divided by 360, so my 360's cancel, and I'm left with just theta. So theta is equal to 70 degrees. So that angle is 70 degrees. Okay. So if we go back then, what questions are you doing today? Well, today you're going to do page 541 and 542, exercise 17.9, question 3, part 2 and 3. I done part 1 in the example. So part 2 and 3, so it's the same as part 1. And question 4, part 2, so again I done part 1 as an example, so it's the same as that. And then I want you to have a go at question 5. So question 3, part 2 and 3, question 4, part 2, and question 5. Okay? So question 5 then can be a bit tricky. So I'm just going to show you there really quickly. Okay, so we have an arc like this one. Okay. And you're asked to find the area of the shaded region. Give your answer correct to 3 significant figures. So find the area of the shaded region. So how are you going to find that? So some of you will be fine on that and you can go ahead and get started. Okay. Some of you can go ahead and get started. So you have to find the area of the shaded region. Okay, so we know that we're given in the question that this is 40-degree angle. We know that this is 10 meters and the full length then is 15. From here to here is 13 meters and the full length is 15. Okay, so how are you going to find that shaded region? How do you think you're going to go about doing that? Okay, so lads, what I'm seeing there is I'm actually seeing 2 shapes. So I hope you can all see that. Okay, I'm seeing 2 shapes. I'm seeing an arc that we've been working on. So this full arc here. Okay, the arc I'm seeing. We know what the radius is, we know what the angle is. So we can definitely find the area of that full arc. Okay? And the other thing I'm seeing, the other shape is this triangle here. Okay? I'm seeing this triangle here. So to find that shaded region then, wouldn't it be the same as finding the area of the whole thing? Find the area of the full section, full sector, and then taking away that angle, that triangle. Wouldn't that give me the shaded region? If I found the whole arc, so using the formula to find the area of an arc, so using your degree and your full length, and then if I find the area of the triangle and took it away, sure that'd be just I'd be just left with the area of the shaded region then if I took away that triangle, wouldn't I? So I think that's how you're going to go about doing it. So remember the formula for your area of a triangle. So it's half AB sine C, remember? So give that one a go as well. Okay? And guys, the 3 significant figures then, it's not 3 decimal places. Okay, that's what a lot of people think 3 significant figures is, that it's just 3 numbers after decimal point. It's not that, okay? It's the first 3 non-zero numbers. Okay, so it's the first 3 non-zero numbers. We did that at the start of the year. You might have forgotten. We don't come across it very often, but it always sneaks in somewhere. So just to be mindful that it's not 3 decimal places. Alright, it's not the same thing. It's 3 significant figures. So it's the first 3 non-zero figures. First 3 non-zero numbers. Alright, so I leave you off there and get going on those. So lads, again, make sure, it's really important you submit all your work. So make sure you get those done and make sure you submit them. Alright, don't forget to correct your work and upload it, okay? So page 541 and 542. Exercise 17.9, question 3, part 2 and 3, question 4, part 2 and question 5. Any problems, let us know. Okay? Thanks, boys, and enjoy your weekend, okay?